afternoon and good morning some places in the world. Welcome back to our third session of Abza Digital Solution Summer Series. As you already know, my name is Eugenie Manzafasha. I'm the event coordinator. We always together each Friday. So today we welcome, or we are hosting World Resources Institute, a company we are together today. So without taking much of time, I welcome Jack Stockman, who is the speaker today. And Jack, maybe you can start with introducing yourself and the World Resources Institute as well, before you take us through the presentation.
Of course. Thank you. My name is Jake Stockman. I'm a researcher at the World Resources Institute, where I support the Energy Access Explorer. The Energy Access Explorer is an interactive open source tool that is available to support integrated and inclusive energy planning in several geographies in sub-Saharan Africa and also for some states in India. The World Resources Institute is a global non-government organization that conducts research and advocacy in the energy space, as well as several other themes such as cities, climate, etc. So without further ado, I will introduce you to the Energy Access Explorer tool. Okay. The Energy Access Explorer tool can be accessed at energyaccessexplorer.org. This is our homepage. And then from the tool, you can select from the different geographies. For today's demonstration, I'll be taking us to Kenya, which is one of the original 3 geographies where the Energy Access Explorer tool was prototyped. In Kenya, we also have some subnational versions of the platform, currently available in Narok, Bungoma, and Makueni counties. So the possibility for directed interventions at the subnational level is also supported in the platform. Today, we'll be looking at the national level. So before I get started, we'll just briefly orient you to what you're seeing on the screen. On the left-hand side, we have several of the functions that are available in the tool, most of which we'll explore in greater detail further on in the demo. There are 2 views. The data view is where users can add and overlay different data sets. And then the analysis view is going to combine the data sets that the user has selected to identify priority areas for energy access interventions. On the right-hand side of the screen, we have some features like the zoom in, zoom out. You can also use the wheel on your mouse or the scroll feature for that, selecting from different base maps and projections, and then also the ability to query features. The data sets that you've selected will appear in the right-hand side. And then in the bottom right-hand window, as we go through the demonstration and start adding data, you'll see a preview of the analysis that's being generated behind the scenes. So let's get started. The data sets are categorized according to demand, supply, data from the census, and some additional data sets. We'll start on the demand side. I'll add population density. Now for this or for any other data sets that are included in the Energy Access Explorer, by clicking the 3 dots on the right-hand side of that data set, you can pull up the dataset info. This will provide detailed metadata documentation for that dataset. That includes the year, the source, resolution, as well as links to the original. Next, I'll add the relative wealth index. For today's scenario, we'll be focusing on mini-grid development. So we're going to take a slightly more market-oriented approach. The relative wealth index is designed to, it's a multi-indicator index that is designed to show areas relative to the median wealth in the country. So the median wealth would be 0, -2 to 2 are going to represent respectively areas that are below or above that median. So that can be used to assess willingness and ability to pay, which for private sector developers is going to be critical information. You'll also see on the demand side, we have several productive uses that we can feature. Those include schools, healthcare facilities, as well as mines. So if you were interested in identifying, some of these anchor loads, that information is also available on the demand side of the platform. Moving on now to the supply side, we've got two subcategories here. The first is looking at the resource availability. For today's demonstration, we're going to be focusing on off-grid solar solutions. So I'll add the global horizontal irradiation. And just reset that there. We'll play around with some of those filters and buffers a little bit later on in the demonstration to show how users can target the analysis for specific objectives and use cases. Next, we'll look at the infrastructure. So we'll want to make sure that we know which areas are currently connected to the grid and which areas are not. So I'll add the distribution network. As you can see, there are some different, you can see the different voltages displayed as well. So if you wanted to only show, for example, the 33 kilovolt lines, then you could uncheck that other box and those other lines would no longer be included in your analysis. Just to show that feature off, I'll add those back so that we're capturing the entirety of the network. And then we'll also want to take a look at where existing mini grids are, just to make sure that we're not duplicating existing efforts. I'll add a few additional layers that I think will provide some critical context. One of those is protected areas. We'll want to make sure that this development is occurring in places that are not currently under protected status. And then finally, I'll add a crop cover layer. And this can help us to identify those sites where crops are being grown to help support productive use and crop processing, cold chain, some of those irrigation, some of those additional applications where off-grid energy solutions can provide a lot of benefit. So I went through that rather quickly, but while I'm still in the data view, I'll demonstrate how users can click and drag and overlay those data sets in different orders. So if I wanted to see, for example, where the distribution network corresponds with solar resource availability, I can add that here. As you can see, some of the highest potential areas of the country are actually located quite distant from the grid. So just an interesting observation there. And you can click and drag to update that order to best suit your needs. Additionally, you can adjust the opacity of a layer. So if you wanted to see underneath it, for example, or reduce the brightness on your screen, that's also a capability in the data view. So now that we've added some relative data sets, some relevant data sets, let's take a look at the analysis. So you'll see here some of these areas have automatically been filtered out. So those areas that are included as protected areas are not being included in the analysis. Also, areas with populations that were too low to be included in the relative wealth index are also being excluded. If we did want to consider some of those areas, we could restore them by simply deactivating that layer. I would like to use it for the analysis today, though, so I'll bring it back. So in addition to the output that you're seeing on the map, in which each of these colors corresponds with a level of potential, you also will see the area and population that fall into those areas. So there are 5 buckets ranging from low to medium to high, each of which corresponds with one of the colors that you see on the map and the corresponding charts here. So just by hovering, I can see that around 11% of the area that's being included fall, or 11% of the population falls into high suitability categories. This is the energy access potential. That's just one of 4 indices that are available in the Energy Access Explorer. The energy access potential is looking at both the supply and the demand sides. So we sometimes call this the low-hanging fruit. These are the areas that have the most promising potential on both demand and supply for electrification in the short term. We can also break that down into its 2 components. So when we look at the demand index specifically, it will highlight more some of those more urbanized areas. And then on the supply side, some of those areas that have higher resource and infrastructure access. Finally is the assistance need index. This is going to show areas where there is an ongoing need for electrification, but where there may be some requirement for incentives beyond the market in order to reach some of those more vulnerable populations. For this example, we're going to use the energy access potential. So what we're seeing now is the raster analysis. So this is this is calculated at the square kilometer resolution. So every square kilometer that fits the inclusion criteria will be given an index score based on the selected index, in this case, the energy access potential. We can also look at that at the county or sub-county level if we wish to see those aggregates. So we've added some of the data sets that are of particular interest to us based on the type of analysis that we're performing today. So let's show how filters and buffers can be used to further hone in on areas that have the highest potential. So as you recall, we're focused here on off-grid. So I'll set a 5-kilometer buffer from distribution lines so that we're focusing on areas that are distant from the grid. And then I'll do the same for mini grids just to ensure, in this case, 10 kilometers, just to ensure that we're not building in areas that have already been served by mini grid developers. So applying those filters, we still have more than 45,000 square kilometers of the country that fall into our area of analysis, and about 2 million people who are living in those areas. Once again, if I wanted to see that at the county or sub-county level, I could change the unit of analysis to show that instead. So now that we're focusing on off-grid areas, we're seeing a rather different outcome in terms of those prioritizations. So now that we've generated a relatively basic scenario, let's take a look at specific locations that may be of further interest. So using the top locations tool, we'll see a ranked list of the top 20 locations in the country according to the user selected criteria. So if I were to apply different filters, buffers, add some additional data sets, then these would change correspondingly. All of the analysis in Energy Access Explorer is conducted on the fly, meaning that it will respond in real time to changes specified by the user. So let's take a look at this area. This is it has an index score of 100, meaning based on the selected criteria, it is the most promising location in the country. Now, I'd like to just take a minute to verify what that looks like. So I can change the base layer here. So I'll pull in some of that satellite imagery. And then I'll reduce the opacity here. And now when we zoom in onto that site, we can see here that this is an agricultural village. And according to the analysis that we've conducted, So we're looking at cropland areas, we're looking at proximity to population centers. For the productive uses, we've selected mines. So if areas that are in close proximity are going to have higher scores in the index. So here we can see that particular example. To go to the next one on the list, I could simply click there and then we can do the same type of ground truthing analysis. So while this is not a substitution for detailed site visits, it can provide a short list of potential locations at a very quick and easy analysis using an open source platform. So in terms of what this means, it can save a lot of time and resources that otherwise might go to exploring places that might have lower potential. So that when you are in the field studies and project design phases, you can focus specifically on some of those areas where the impact can be highest. So finally, the last feature that I'd like to show before concluding today's brief demonstration, let me just reset my view here, is the ability to focus on a subnational geography. So all of the counties in Kenya are going to be included here. So let's see, where is Turkana? So now I've focused my analysis. So it is only showing the points that fall within that particular county. In this example, I've selected Turkana, but you could also, if you wanted to go back to the national level, you would just select up a level. And once you have selected a county, the list will change to show the sub-counties there. So each of those sub-counties can then also be focused on. In addition to the changes showing on the map, also the area and population are going to adjust correspondingly. So within this particular county in Turkana County, there are nearly 400,000 people that are living in these high potential off-grid areas. And then if I wanted to focus on a sub-county, then I could further refine that analysis as well. So returning now to the national level, all of the analyses that are conducted in the Energy Access Explorer can be exported. So to export it as a TIFF file that can be used in another GIS platform, you could use this download TIFF. Also, we have a built-in report called the snapshot. So the snapshot is going to show not only the energy access potential, but also some of those other indices. In addition to the charts, you'll also see tables. So the tables will show for each of the 4 indices and each of the 5 levels of suitability, the area in square kilometers, and the population that falls into each of those areas. This can be exported as a PDF or a CSV file. So that can be used in reporting and can provide some detailed information on the analysis that we've conducted. So with that, I will conclude today's demonstration. I encourage you all to take a look at the tool, play around with it a bit on your own, and we look forward to continuing to develop this tool in the future, working with local stakeholders and data providers to provide up-to-date, complete, and reliable data in order to serve various user needs. Thank you for your attention, and I look forward to being in touch with you all as well.
Thank you very much, Jack, for a very good demonstration. So I have some questions. The first question that I have, I really want to know, or maybe you have highlighted some, but what are the users of this platform? So when you were presenting, maybe I understand like project developers who want maybe to know the specification of the location they want to go to, maybe build and implement some project. But what are the other users of this platform?
Yes, great question. So we have four user groups that four broad user groups that we target with the platform. One of them, of course, is project developers and other private sector stakeholders. So that anyone who's providing equipment and services in this sector. It is available to anyone on the web. So anyone with a web connection can perform the same kind of custom high-powered analysis that I demonstrated here. But in addition to the private sector, we have three other user groups that we focus on. The first is integrated energy planning agencies. So in Kenya, that could include the Ministry of Power, and basically looking at high-level decision-making about grid expansion and linking that energy planning to the broader socioeconomic development in the country. Another user group that we like to target is service providers. So that can include healthcare, it can include education, agriculture. I used mines in this example. So some of those other ministries and those who are involved in those sectors as well can use the Energy Access Explorer to identify some of the links and opportunities at the nexus between energy and their areas. The next group that we like to target is international donors. So whether that is financial institutions like the African Development Bank or bilateral donors such as USAID, those users as well can use the tool to help to identify areas that are priorities for grants and support in providing electrification services.
Okay. Interesting. You've mentioned that everyone on the web can access the tool. Does it require maybe some logins or having an account to access the data?
Yeah, it does not require an account to use. I will say, however, that we also have a password protected version of the platform. So for government stakeholders, for example, you can access data sets that maybe are sensitive or proprietary in nature that you, for whatever reason, wouldn't want to release to the broader public. We do always encourage, in the spirit of collaboration, open access to data. The Energy Access Explorer is an open source tool, so all of our source code is available on GitHub. But we do understand that there may be some data sets that are not suitable for the general public. So there is an opportunity to protect those behind a password. And on the back end of the platform, we have a content management system where administrative users can not only add and update the different data sets that appear in the Energy Access Explorer, but also control user access as well, and even customize some of the visualization and configuration settings.
Okay, and this is if maybe someone want to further access, I mean, for those who can only access those data available, is it any way maybe I can pass through either maybe writing an email or any contact that I have to reach out to ask more data?
Yeah, great question. So there's contact information available on the Energy Access Explorer page.
Mm.
So from our homepage, if you go to Get Involved, then there are links. So we have our contact information here. You can subscribe to our mailing list. Also, for users of the tool, we encourage you to submit testimonials. And some of those will be featured on the user stories section of our website as well. Another channel that you can use to get involved at the national level is through something that we call the Energy Access Explorer working groups. So in each of the countries where we work, we collaborate with local stakeholders, usually ministries of energy or rural electrification agencies. And through them, we convene different stakeholders on a recurring basis, so annually, biannually. And those offer another opportunity for interested stakeholders to get involved, whether that's contributing data, whether that is sharing a particular use case that they'd like to see better supported in the platform. We like to encourage open dialogue and make sure that this platform is continuing to evolve to best meet the needs of our users.
Okay, I think I have a run of question. I also have one question, maybe as someone who interact much with the platform. How accurate is the platform? How does the accuracy of the data found in this platform? Another maybe question can maybe also answer them both. How often do you update the data? Is it quarterly? Is it year basic? How regularly you update the data?
Yeah, great questions. So any model, the Energy Access Explorer included, the outputs are only going to be as reliable as the data that goes into it. So we do a couple of things to ensure the quality of that data. So the first, as I mentioned, is the working groups. So having these regular convenings where stakeholders, so whether those are data providers or users of the platform, can provide feedback on the data that's currently existing. Another way that we verify the data in the platform is to provide detailed metadata for all of the indicators. So anything that you're seeing in the Energy Access Explorer, we ensure is well documented. That includes also links to the source itself. So if you have questions about how a particular data set was collected, that information can be found by the users. That includes as well the date of the content. And then finally, we conduct detailed scoping exercises in the initial phases of implementation in each of the countries where we work. So one of the advantages of the Energy Access Explorer is that it can take data from a variety of different sources and scales and combine them all into a single platform for users to be able to access. So that can include global data sets. For example, here, the Global Horizontal Irradiation, that comes from the World Bank's Global Solar Atlas. Many of the data sets come from national stakeholders. So in the case of Kenya's distribution network, that was provided by a ministry in Kenya. And then we also have the ability to bring in subnational data. So in this demonstration, I showed the national version of the platform, but for some of our subnational geographies, so the counties that we currently support, just to reiterate, that is Narok, Bungoma, and Makueni, with plans to expand to others in the near future. We have some slightly more detailed data sets. So things like agricultural cooperatives, the kind of data that would be difficult to source at the national level, but when we work with subnational stakeholders, we can provide some of that more detailed information. So we take it very seriously, making sure that the data that's included in the platform is as reliable as possible. There's no such thing as perfect data, unfortunately, but we do have a very rigorous process in validating any data sets that are uploaded.
Interesting. Yeah, I think that was my final question. I hope the audience might find the talk very useful, particularly for those who are in data research position and data collection within different companies. Thank you very much for your time.
Thank you so much. And also a big thank you to AFCEA for the work that you're doing across the continent as well. I would encourage anyone who is watching today to reach out to me if you have any further questions or to the email address on the website.
Yeah.
And I look forward to being in touch, and hopefully together we can make this platform even better.
I want to make some announcements. So as usual, we are having also another series Friday on 28th. So we'll be welcoming Sologist. So hope to hear more regarding digital solution. So plan to do not miss. And also I want also as well to remind you our event in Nairobi, which will take place Service Expo Center. So if you are a developer, if you are an investor, so please plan to come. It will be a very good event where we will promote investment in renewable energy in Africa. So plan to do not miss. So I also want to give you maybe some seconds to take some notes of this email appearing to the screen so that you can reach out to any event organizer. So if you are interested in conference and the program, so I mean being speaker, so feel free to email those two people. If you are interested in exhibiting, so feel free to reach out to me. So also we are having a NACSA award. If you feel like you have done so much in this industry, so the application is now open. So feel free to stay tuned on our social media, and then you go ahead and apply. If you know someone you want maybe to nominate, we have different categories. So go there and learn more and nominate your friends, your supervisor. And again, I thank you all for joining us. Jack, thank you very much for your time, and I wish you a very good rest of your time today.